Good afternoon, friend. I am Rohit Maurya, and today I will teach you what is gas hydrate and why it is needed and why it is important and the occurrence of the gas hydrate in the Indian scenario and as well as in the global scenario. And also we will see the identification of the gas hydrate, means if it is found at the any place on the surface or in the subsurface or at any place in the earth, then how we will identify, how we will explore it. So friend, we will first see why it is needed, because we all know that worldwide population is increasing and economics and the demand of energy resources like natural gas is also increasing, and therefore the supply of conventional energy resource like natural gas is declining because we are using from a long time. Then to meet the increase in the demand of the energy, we need the unconventional form of energy like gas hydrate. Then what is gas hydrate? The gas hydrate are the crystalline solid with molecular structure similar to that of ice, and it is also known as clathrates, also known as methane hydrate, and it is formed under the high pressure and low temperature condition. It cannot be formed anywhere. It is certain temperature and pressure condition where it can form. The temperature and pressure condition regime is temperature should be low and pressure should be high. And what will be the temperature and pressure we will discuss later. But at this point you focus only on the gas hydrate is a crystalline solid whose molecular structure is similar to that of ice. Okay, and it is also known as clathrates and methane hydrate, and it contains the immense amount of energy, almost twice of the energy contained in the fossil fuel, which is conventional fossil fuel. Okay, here you can see that the block diagram of the methane hydrate. This is the methane hydrate, which is also known as gas hydrate. Here you see the case like structure. Inside it there is a brown color you are able to see. This brownish portion is gas and this is ice case. It is showing that the methane hydrate, means gas hydrate, is composed of gas plus hydrates, which means water. Gas which is normally methane, so because the proportion of gas is 99% and the proportion of water is only 1% to form this hydrate, means gas hydrate. So if 99% of methane gas and 1% of water mix and form a clathrates as ice like or case like structure, then it is known as gas hydrate. And if you will see the proportion of gas to water ratio, gas to solid ratio, then it will be 160 ratio 1, means 160 part will be solid, 160 part will be gas and only 1 part will be solid. Here and large reserves of the gas hydrate have been found all over the world. We have seen that in India as well as in different part of the world we have found the different at different location the a different amount of gas hydrates. And it is normally gas hydrate can be identified by the geophysical techniques like seismic and the well logging. In seismic, the most prominent indicator is the BSR, which is known as bottom or basement simulating refractor, which is very clearly visible on the seismic section wherever we found the gas hydrate. And the well logging also play a very important role in the characterizing the gas hydrate deposits. My friend, this is the different chemical structure of the gas hydrate. Here you can see the hydrates molecules numbers. You can see in this type of structure the hydrated molecules is 46 and 136. Here you can see 32. Okay, so I'm not going into the deep chemistry of the gas hydrate, but just see there can be different type of this case clay threads gas hydrates molecule. Here you can also see this is schematics of the gas hydrate stability zone. Means before this I tell you na ki where everywhere we cannot find the gas hydrate. There is certain temperature and pressure condition where we can get the gas hydrate. This is the graph by which we can understand the where we can find the gas hydrate. This vertical graph is showing the depth, and this horizontal is showing the temperature. So here we can see that this green one is showing the phase boundary, and this red one is indicating the geothermal gradient. It is cutting at 2 points here and here, and where it is cutting this phase boundary curve, this is showing the stability zone for the gas hydrate. Here you are here you can see it is written that top of the GHSZ. GHSZ means gas hydrate stability zone. Means this is the top of the gas hydrate stability zone, and this is the base of the gas hydrate stability zone. Within these two we can find the gas hydrate. And this is the from surface to this is going below, that means depth is increasing. And this is 0, this is 200 meters, because here you can see that depth is given in meter. And we found the gas hydrate in both area, that is on land we can find, and as well as we can normally we found the gas hydrate in the marine environment. In the land portion we found the gas hydrate in the permafrost region. Okay, and here you can see that the temperature for the gas hydrate stability zone is approximately 15 degrees Celsius, from -5 to 15 degrees Celsius. Here you can see that in marine environment the temperature condition for the gas hydrate occurrence is approximately 5 to 15 degrees centigrade. Coming to the next slide, here we can see that the occurrence of the gas hydrate. This is the global scenario and this is the Indian scenario. Here you can see that Indian Ocean, Pacific Ocean and Atlantic Ocean, everywhere we are getting the gas hydrate. And in India, the most prospective zone for getting the gas hydrate is the Krishna Godavari basin, which is also known as KG basin, and Mahanadi and Andaman basin. This is the Andaman basin, this is the Krishna Godavari basin, and this is the Mahanadi basin. This is the most prominent area where we can get the where we have got the gas hydrate. And in Kerala Konkan basin and the Saurashtra basin are also the region where we get the gas hydrate. This is the global gas hydrate reserve. This is the TCF in TCF unit, that means trillion cubic feet. This is the calculated by various scientists. Sorry, you can after taking the 3D seismic data, here we will study about the identification of gas hydrate. Suppose in area, you have taken the data and you want to know that whether we can find the gas hydrate or not. Then first we take the 3D seismic data, okay, then after and then apply the seismic processing steps and find the and ultimately we find a seismic section. By seeing this seismic section, whether we can tell here we can get this gas hydrate or not, this is known as interpretation. Here we will with the help of this seismic section we can tell if there is a presence of gas hydrate or not. The property of gas hydrate is that if there is presence of gas hydrate, then we will find in the seismic section a anomalous seismic reflector which will just mimic the bottom of the seafloor, which is known as bottom simulating reflector. Okay, so here we can see that this is the anomalous structure because the amplitude is very higher, and if we see that, then this is our seafloor. Okay, and this one is mimicking that reflector. That means if there is any anomalous reflector is present in the seismic section and it shows the anomalous amplitude also, then it is indication of gas hydrate. That means this because this is anomalous structure, this is anomalous reflector, as well as this is mimicking the seafloor, bottom of the seafloor. That's why it is a bottom simulating reflector, because this seismic section have presence of the bottom simulating reflector. That's why it has a highest probability that we will get the gas hydrate here. This is the another seismic section. Here you can also see that this is our seafloor, bottom of the seafloor, this one, and there is one anomalous structure also present here. You can see because seafloor is going like this, okay, and this anomalous structure is also going up like the seafloor, just mimicking means just repeat the pattern of the seafloor. This is mimicking the pattern of seafloor. That's why it is a bottom simulating reflector, and because this section contains the bottom simulating reflector, that means this area also have probability of getting the gas hydrate. How we will confirm that? Suppose I am taking the 3D seismic data and find this seismic section, and on the behalf of this we are saying that this is the gas hydrate and this is the gas hydrate. And how we will confirm whether this is gas hydrate or not? Because this type of anomalous reflector can be arises from some other features also. And how we will confirm that this is no, this is this anomalous reflector is coming from the gas hydrate? How we will confirm? To confirm this, we use another geophysical technique, which is known as well logging. Here you can see the some well log data, and this yellow strip is showing the zone of gas hydrate, because as we know that the gas hydrate means it is a clathrate, or it is a case of gas and water, ice like case of gas and water, because it contains gas means it has lower conductivity, that means it have a very high resistivity. Okay, because the gas hydrate is only composed of the gas and water, there is no radioactive substance, then their radioactivity should be low. Okay, and also the PV velocity in the gas hydrate zone is come high. Okay, we get the seismic PV velocity high in the zone of gas hydrate. Then here you can see that this is the zone where we are getting the gas hydrate. Here you can see that the gamma ray value is low. This is the 0 value, this is 100, means if the curve is moving from here to here, that means energy it is increasing, radioactive substance is increasing. But here we are getting that we are the gamma ray value is low, that means there is no radioactive substance and it is constant, almost constant. And in the zone of the gas hydrate zone, we get the neutron and density porosity very high. Here you can see that the porosity is high, approximately 0.7, that is 70% almost. And the resistivity, because the presence of gas, the resistivity is very high. And here we can see that the PV velocity is also very high. That means all the physical parameters, all the physical characteristic of the gas hydrate is fulfilling. That means we know that if there is presence of gas hydrate, then resistivity should be high. Then here we are seeing that resistivity is very high, velocity should be high, velocity is also high, porosity should be high, porosity also is very high, and gamma ray value should be low, gamma ray value is low. So our conclusion is that because all the physical parameters are fulfilling for the occurrence of gas hydrate, that means in this zone the presence of gas hydrate is confirmed. Thank you friend. I think आपको कोई वीडियो पसंद आया होगा, और प्लीज़ जो है आप कमेंट करके ज़रूर बताएं वीडियो आपको कैसा लगा।